Welcome to Algebra, solving literal equations. Up to this point, all the equations we've explored have contained only one variable, usually x, but sometimes y or a or n. It doesn't really matter. When an equation contains two or more variables, such as x, y, and even a or b, these are called literal equations, and we solve for one of the variables in terms of the other variables. This will eventually lead to the study of linear, quadratic, and exponential equations, representing lines and various types of curved graphs, as well as other equations such as area and volume of 2D and 3D geometric figures. Here are some classic examples of literal equations. E equals mc squared is the famous equation in Einstein's theory of special relativity that expresses the equivalence of mass and energy. A squared plus b squared equals c squared is the well-known Pythagorean theorem, showing the special relationship among the three sides of a right triangle. The area of a rectangle is expressed as area equals base times height. This is the equation showing the mathematical conversion between Fahrenheit and Celsius. This is the linear function equation in slope-intercept form, y equals mx plus b, that you will study later on in this course, the one that represents a line on a graph. Here is the standard form of a linear equation, ax plus by equals c. Notice how all these equations have at least two variables. They are all literal equations. The steps for solving are the same, but the answer contains a variable instead of just a value. Here we have a one-variable equation, which we solve by adding 4 to both sides, dividing both sides by 2, and we get the answer x equals 8. Here we have another equation with two variables. It looks almost the same, except now the 4 is an a, but we solve it exactly the same way. We add a to both sides, we get 2x equals 12 plus a. The 12 and the a cannot combine because they are not like terms. We divide both sides by 2, leaving x isolated on the left, and on the right, 12 plus a divided by 2 simplifies to 6 plus a over 2. Let's look at the linear function equation in standard form and solve for y to convert it to slope-intercept form. The standard form in this case is 4x plus 3y equals 6. We want it to look like slope-intercept form, y equals mx plus b. We subtract 4x from both sides, leaving 3y on the left equal negative 4x plus 6. We divide both sides by 3 and then simplify to get y equals negative 4 over 3x plus 2. It is now in slope-intercept form. This is a classic process you will perform many times throughout your study of algebra. Learn it well. To show you what this equation actually means, here is the graph of the line this equation represents. You will learn more about this in a later unit. Notice how it crosses the y-axis at 2, goes downwards because of the negative x coefficient, and for every 4 steps it goes down, it goes 3 steps across. Here is another example solving for y in terms of the other parts of the equation. We add 10x to both sides, and we get 5y equals 10x plus 15. Divide both sides by 5, and we get y equals 2x plus 3. Here is a math equation solving for the width variable in terms of the other parts of the equation. A equals 5w, divide both sides by 5, w is equal to a over 5. Here is the perimeter equation for a rectangle solving for w, the width, in terms of the other parts of this perimeter equation. 2l plus 2w equals p. We subtract 2l from both sides, and we get 2w equals p minus 2l. Divide both sides by 2, and we get w is equal to p over 2 minus l. Here we take an equation containing only variables and solve for m. This is the slope-intercept form we looked at earlier. Solving for m, we first need to subtract b from both sides, and we get y minus b equals mx. We divide both sides by x, and we get m is equal to y minus b over x. The same equation is solved for b. We subtract mx from both sides, isolating b on one side, and we get b equals y minus mx. Here we solve for x, the same equation, subtract b from both sides, and we get y minus b equals mx. Divide both sides by m, and we get x equals y minus b over m.